So in this video, we're going to be talking about the vertex of the quadratic formula and how we use it to find domain, range, minimum, and maximum values and graphing. So before we do that, let's look at our Desmos and get a quick refresher of our parabola. So here's our parabola. Remember, we have the three letters, our A, our H, and our K. And if we look at our A causes it to vertically stretch. And if it's negative, it causes it to reflect down and then vertically stretch. But whatever that number is, let's get it away from the 3 so we can see it. So here it's 5. It's from the vertex. We go up 5 over 1. That's because if you plugged in 1 and squared it, you would get 1. And then it'd be multiplied by 5 and you would get 5. So by plugging in 1, you get 5. If it was 6, 7, by plugging in 1, you get 7. So it tells us to go over 1 up that many units, even if it's negative. So this is negative 4 now. So we would go over 1, down 4, or down 4 over 1. And it's symmetric, so we go both sides, even over here. We have that same number. And then we have our, let's move this back to a positive here. We have our H. And if you remember, our H causes it to move left and right. And right now we have a minus 1. And you notice our graph has moved to the right one. So inside is always opposite. If we have a minus 4 inside, our graph is at positive 4. And if we have a minus 5, a positive 5, we move it to the left 5. So it's always opposite whatever that number is. And then our K moves it up and down, exactly what the number should be. So if we have a positive 4, that means our graph has moved up 4. But more specifically, these two numbers give us our vertex. So it's negative 1, so it's positive 1. Positive 4, so it's positive 4. So it's always opposite, same. So 1, 4 is our vertex. If I move it to the left, and then we go down, you can see here it's positive 5, so we're at negative 5, and negative 2, so we're at negative 2. Opposite, same. Moving it over, same thing. Now it's at 3, negative 2, and so on. So it gives us our vertex on wherever they are located. These two numbers, it tells us what our vertex is. So, looking here, if we take the opposite of negative 1, we get positive 1 and negative 5. That's our vertex. Negative 1 is now positive 1, and then the y stays exactly the same. So it's 1, negative 5. That's our vertex. And then we also need our a. Remember, that's going to cause it to translate. So we're always looking at f of x equals a, x minus h squared plus k, so that it's opposite, same, and then the a. And so we know from this that from our vertex, we will go up 2 and over 1. So from that vertex, we go up 2 over 1, put a dot, up 2 over 1, put a dot. And then now we have our parabola. Just like that. You get our nice parabola. So we have these 3 points every single time you graph, and it's that quick. Now we can see our domain. Our domain is always going to be negative infinity to positive infinity because we are talking about a parabola. And there are no issues here. You can plug anything you want into that parabolic function. We can plug a 4, a 7, a negative 10, 100, a 5. All real numbers will work. Our range, however, is always the vertex. So from here we are starting at, if you look at our range, the lowest number we have is the y-coordinate. So if you have 1, negative 5 as your vertex, you already know that we are starting at negative 5 and going off to infinity. So that vertex tells us, whatever the y-coordinate is, it tells us what our range is. Domain is always negative infinity. And it also gives us a minimum value. So if we have 1, negative 5 is our minimum value. And the x just tells us when it occurs. So if we were to plug in 1, we would get negative 5. And that's it. So just from the vertex, we were able to pull out what the range is and what the minimum value was. So let's look at another one. So what is the vertex here? So the vertex here would be negative 4, 2. And my a, if there's nothing listed in front, then we know it's negative 1. So plotting these, we know it's negative 4 and 2. And then from that point, we will go down 1 over 1 to get those points. Put them in red so they stand out. And then we graph our parabola. So again, our a is -1, so from there we go down 1 over 1. It's always over 1. All right, so now our domain, same thing. All real numbers, plug anything you want in. But our range, taking our y value again, is now the highest point. So if it's the highest point, that means we are going from -infinity to 2 and bracket. And it's a bracket because as we move up this graph, remember these come down forever. As we go up, it's from -infinity all the way up to there. So this is the highest point and we're going down. So this is our range here. So it would be from -infinity to our highest point, +2. It's a -infinity. All right, and then the min value, same thing. The minimum value here is not minimum, it is a maximum. So the maximum value here is 2 when x is equal to -4. And how do I know it's a max? Because we are increasing to that point and then decreasing away from that point, making it a maximum value. So it's the highest point the graph is going to go. So it's a maximum. Okay, one more. So what's our vertex here? So if you notice, there's nothing inside. There is no parenthesis. So it's really like we're saying this. So it's 0. If there's nothing there, no parenthesis around the x squared, we know our x coordinate is 0 for the vertex and -1 for the y, and our a is a half. So if we plot that point, 0, -1, now we move up a half and over 1, up a half and over 1. So we would be at 1, 1/2 for our 2 points. And then we draw our graph. So our domain again, -infinity, +infinity. And our range is based off of this guy. So if it's -1, we know that we're going to be starting at -1, going off to infinity. And here our minimum value is -1 when x is 0. So that vertex tells us again everything we need to know about our graph. It tells us the minimum value. It tells us where the range starts or stops. So if it's positive, we know it's a minimum value. And if our a is negative, we know it's a maximum value. See, it's nice. All right, thank you.